let's put product rules with trig. So again, I said, like, that's why we took all those quizzes on change, product, quotient. We wanted to make sure we really, really knew how to do them. We just had a unit circle quiz this morning.
Yeah, but like another
Quizzes.
70.1.
No. How about? All right.
Yeah, I got a bad grade.
Oh yeah.
Y prime or dy dx becomes what? The first times derivative of the second. So derivative of sine is first times derivative of the second plus the second times derivative of the first. So what you're going to want to do is either start putting these dots or getting really good at using parentheses, because you don't want to mix up plus signs, because once we start getting quotients and chain rules, we tend to lose things. Clean this up. Algebraically, it becomes x squared cosine x plus the variable and coefficients always come in front of the trig, 2x sine x. That's it. That's your derivative.
Wait, what is it?
Cannot be simplified or altered.
That's not half
I
bad.
have that.
That is easy. That's what I did.
Just look at number 2.
Wait.
Okay?
No, I think number 2 is pretty fun.
Secant over 1 plus tan. So we have a quotient rule. dy dx equals the denominator times derivative of the numerator. Derivative of secant is secant x, tan x, minus the numerator times derivative of the denominator. Derivative of 1 is derivative of tan all over 1 plus tan x squared. What's in the first and in the last? So we have a GCF. Let's see if bringing that out helps us. That would be my next suggestion in this like area. I'm just going to do it here so I have space. I don't want to get too low. So you get tan x plus tan squared x. So remember when you asked me if we needed the other Pythagorean identities?
That's 1.
Tan squared x minus secant squared x is definitely a Pythagorean identity.
It's a 1 with something in front of it.
You have your chart, don't you?
Yeah.
Let's walk through it. I just want you to tell me exactly what it says on our chart so I can show you the manipulation. So how do you have to manipulate that?
Oh crap, it is -1.
Boom, Cody, yeah, first try.
So you have to flip-flop these, right?
Yeah, I forgot to bring it.
Honey.
No. What can you do here? No, you can't anyway, so you're fine actually. Sometimes you can pull out a negative and these will cancel. Sometimes. But that's it.
Let's add, wait, tan x minus what?
You can't this time because if you pull out the negative, this would become negative and then they don't cancel. But there are times like you could pull out like a negative and like the denominator in this would cancel.
Yeah.
Oh, so you just get negative secant.
But like this one doesn't work that way.
I've seen many hours of teamwork ahead of us.
I see
many
many
hours
hours
of
of depression ahead of me.
Sorry.
I see it.
If you're ready, you can go ahead and try the next one on the back.
So would we treat? Would we
Wait, so
treat
if that one
negative
cancels
as
out, would you be left with, so negative secant x over 1 plus tan x because it's squared?
Yeah.
Okay.
So on this, would we treat negative cosine x as our second and x cosine x as
So this is a product rule.
a, okay.
So you gotta do first times the root of the second. This is where I said parentheses are gonna really come into play. If you don't parentheses that negative sine x, we often forget when we do our next line and we make it x minus sine x and it's not. So it's first times the root of the second plus the second times the root of the first
Oh.
minus the derivative of cotan x. So the derivative of cotan is negative cosecant squared. So that minus the minus will become a you'll bring that negative on the sine x in front of your x. So it becomes negative x sine x plus cosine x plus cosecant squared x. And you're done.
Oh,
Yes,
I
really.
definitely feel like we're gonna do this.
I know, because it looks all goofy and gross.
I'm gonna just sit down and
Is it possible to go farther?
No. Because even if you tried to like manipulate this, you'd get like cotangents and secants and you'd have to get common denominators and it would just be gross.
And then you'd end up
For no reason.
You'd end up coming full circle right back to this by trying to simplify that. Wait, there's gonna be a lot of zeros here.
Yes, there are. What you're going to see is from now on, if you recognize the zeros, if the product rule is occurring because you see a number in front of a trig function, if there's no variable with the number, you really don't need the product rule. Because the derivative of a constant is always 0. So since that's a constant, it's always going to zero out in the next line. Because it'll be first times root of the second plus the second times root of the first, which will always be a 0. Yeah. I don't know why it's tasted so much.
Just take a while.
You think?
I don't know, just because I'm gonna sit there for 5 minutes after I'm done with everyone, and be like, I'm not done. There's no way this is done yet.
Does it matter if we have the cosecant and cotangent switched?
No.
You keep switching.
Order doesn't matter. I feel like I just kind of write it. You know what I mean? Okay. Homework's in the book.
Yes.
You say hopefully it is. Yeah, hopefully that's multiple choice. Those are multiple choice, right?
Oh.
Those won't take as long as every single one of these, right?
No, the bad thing about it is then it goes
Well, I mean,
one A through E.
yeah,